Thank you, Jen. I'm very pleased to welcome everybody here. It's great to have a good crowd from different sources, and I'm pleased to introduce our speaker, Jon Kleinberg from Cornell University. He got his undergraduate degree there, and then he went to MIT for master's and PhD, returned to Cornell, where he is a named professor, a distinguished member of the faculty. But Jon's a really remarkable, accomplished scholar, so I'm very pleased he's the one to kick off our 30th anniversary events. His book, with economist David Easley, Networks, Crowds, and Markets, is a remarkable piece that's used for his course of 450 students a semester. And so it draws a remarkable diverse set of people to this common course. And this book will change your life, and it's an education that's quite substantial. Jon's made important contributions, and what I really like about Jon is the way he uniquely bridges the gap between the communities represented in this audience here. His early work I came to know about the hubs and authorities was a really important influential work, and it was cited by Sergey Brin and Larry Page and Terry Winograd in their key paper about the PageRank algorithm. And I was appreciative that Jon cited our work with graduate students here, Rodrigo Botafogo and Ehud Rivlin, that was developing an earlier set of ideas. Jon had made a much more lucid presentation of this notion, and that's sort of well, I guess to say, of course, Sergey Brin was one of the students who wrote Maryland as well. That was the further connection with Maryland. What I really like about Jon is his crossover and bridging between these multiple disciplines. He's able to take the deep algorithms in computer science, make the insights, and attach it robustly to the human dimension. There's a lot of work on graph theory that preceded his work. That was done many times by physicists, but the abstractions there were so great as to take it away from the human dimension. And so Jon successfully integrates the sociology, the psychology, and the human aspects into it, into the computer algorithm. And he said famously in an article in Nature just a few weeks ago, I realized that CS is not just about technology, it's also a human topic. So that bridging notion brought him to new topics and new insights that I think were very important. And he's been recognized in many wonderful ways, maybe most notably in 2005 by the MacArthur Foundation, often cited as Genius Fellow. Jon's very shy, I'm sure, embarrassed by citing all of these things, but his recognitions, many of them, are really well deserved. When I read his papers, I say, I wish I wrote that one. They're marked by a deep, solid understanding of the problem, rigorous algorithmic work, lots and lots of data, and then he takes it out to what the implications are for designers and future workers in the area. So with that, I offer you and invite Jon Kleinberg. Thank you for coming to join us.
All right, I'll kind of move around up here, and maybe I'll end up on the camera, and maybe not. Okay, well, so thanks very much, first of all, Ben, for the invitation to come speak here. It's always a pleasure to be able to visit Maryland, and I always learn an amazing number of things when I come here and come away with new stuff to think about, which is even true in the short amount of time I had here this afternoon. So it's a pleasure, and thanks all for turning out for this talk, and thanks for the nice introduction. So what I want to talk about today was some issues at really the intersection of models of networks and models of behavior in those networks. And in particular, when I think about the kinds of problems that come up in this space, I certainly come at them as someone whose background is in theoretical computer science, who has sort of acquired this interest in these other dimensions of the problem maybe and has explored them. But I sort of think about it at the level of what does this mean for computing systems, and also what can we learn, how can we understand these systems better, right? Because in the end, I think a lot of this is both about understanding and about design. And I think there are interesting questions about how improved understanding leads to better design, and how better designs shed new light on the problem, and how that feedback loop works. So in particular, I think when we think about systems like blogging, online commerce, online social networking, it really represents an enormous broadening of the design problems for information systems, right? So we have all the kinds of issues and constraints that have always been with us, issues like efficiency and robustness. But we now have many other things, right? The kind of feedback effects that you get from dealing with very, very large human audiences, right? And those social feedback effects become an intrinsic part of the design space. And we have to reason about them right alongside the kind of computational issues. So I want to sort of explore that point, right? The expanded design space and the kinds of new insights we can get about even just online human behavior by looking at how these systems are used. And I want to focus it on a particular aspect of the problem. I'm just going to move this little wooden podium thing here. So, all right, that seems to work. So I'm going to focus on a particular aspect of the problem. Settings that you might say involve opinion and evaluation. And I'm going to take that slice through it. Because in the end, that turns out to expose a very, very rich set of issues. And I think one can end up finding out a lot about what this design space looks like when we think about things that involve these notions of opinion. Okay, and again, we'll try to sort of move between models of networks, models of human behavior. It'll try to sort of stay at this level of thinking about abstract models and what they might mean for designs. Okay, and in particular, think about this notion of status is going to be an idea that runs through it, right? So when I form an opinion of someone, that opinion is often influenced or colored by the notion of how I view their relative status to me. All right, so let's kind of move down to concrete details. So the idea of expressing an opinion about somebody else online, right? So there are actually many settings where one person expresses an opinion about another. It's useful to walk through some examples just so we kind of have those at our fingertips. The notion of trust, right? I could say online, I trust you, right? So on, say, the product rating site ePinions, one user can trust the ratings of another, or they could distrust the ratings of another, right? I tend to, agree with this person on political books. I tend to disagree with this person's opinions about digital cameras and so forth. A different notion would be agreement, right? I agree with you, I disagree with you. Obviously in political blogging, we see that. Unlike ePinions, which had that nice designed logo, the political blogosphere doesn't seem to have a designed logo. So I decided to adopt Lotta Adamich's and Natalie Glance's picture of the 2004 blogosphere just before the election as my official candidate for the new logo for the political blogosphere, the kind of hopeless polarization into red and blue. You can agree or disagree, right? With somebody online. Similarly, communities have gatekeeping, right? So I can admit people into the community or not. I can view somebody as deserving of entrance or not. That also is a kind of evaluation, positive or negative, right? And if you look, for example, at Wikipedia, right? That's a very nice example where this kind of gatekeeping is really recorded in great detail, right? So Wikipedia, in a sense, is the ultimate bureaucracy online. It has sort of these rules and these guidelines and these pathways that things follow. And in particular, if you want to become an admin, right? So Wikipedia is sort of policed by this army of roughly, a few thousand volunteer admins who have the power to do a lot of things. They have the power to resolve disputes, lock down articles, expel users, and all sorts of things. And of course, with great power comes great responsibility. And so when you want to become an admin, you actually submit what's, through my academic lens, looks like a sort of tenure and promotion case, right? You actually, right, someone coming to become an admin has often logged, say, 10,000 edits on the system at this point. And they say, here are all the good things I've done on Wikipedia. Here's why I deserve to be a Wikipedia admin. Here are my credentials. And then there's a public discussion and a public vote, right? And so if you vote negatively on that, that's a vote that person is going to remember, right? It's a vote that's sort of public, recorded, and consequential, and it's again an evaluation. And there are many, many other cases where you express this kind of positive or negative notion. And so there's sort of some commonalities here, right? In all these cases, there's kind of a network structure, what I think of you. It can be positive or negative. I can think positively or negatively of you. And that's sort of one theme throughout this talk, right? That the language of online social networks often sort of has these very positive connotations, right? You're always connecting to your friends and your fans and your followers, and everything is all very positive. But there's both positive and negative here. So that's one thing. It has a network structure. The links can be positive or negative. But it's context dependent, right? Depending on the situation, you might mean one thing or another by that negative evaluation. And I'll come back to that and try to separate the different dimensions. And of course, there are always these analogies to offline domains, right? So as an academic, I somehow always think of this in terms of academic analogies, and that this is like academic promotion, and other things are like academic citation. And I'll come back to some of those analogies toward the end, where we'll actually try to travel some distance with them. Okay, so how do we make sense of all these different meanings of opinion and evaluation? I want to organize this first in some kind of theoretical underpinning, where we try to pin down some possible definitions in graph theoretic terms for what these things might mean, and then move on to some practical applications. So first we'll talk about two different contrasting theories of what evaluation might mean, how we can interpret it. And those are going to be the theories of balance and status, which I'll talk about in the next few slides. And I'll talk a bit more about how status is wrapped up with a number of other features like the similarity among different users. So this will be sort of trying to build a foundation for reasoning about these things. And then I'll talk about two recent applications of some of these ideas of status that we've looked at, which actually go in quite different directions. The first is going to be basically how differences in status and power are reflected in language use. Okay, and that's going to be more of an empirical study trying to understand and actually get mileage out of a particular psychological phenomenon in language use, which can allow us to actually develop metrics of power and metrics of how certain relationships evolve. That's going to be more on the empirical side, looking at data. And then this idea that status is a form of incentive, okay? And that when I confer status on people, or when I hold out the opportunity that you could become a Wikipedia admin, for example, that creates an incentive for you to do certain things. And that incentive leads in turn to a kind of game theoretic framework in which we can think about how status-seeking individuals might actually behave. And that's going to be some joint work with my student, Sigal Oren. And that'll be more on the theoretical side. And the aesthetic there will actually be to think about simple models that might capture some of the otherwise seemingly complicated phenomena that we're seeing. Okay, so build some foundation, and then these two somewhat different applications of status. All right. So what do positive negative links mean? There are lots of hypotheses you might make. I'll talk about two that have had quite a bit of longevity in the social psychology literature. The first is the theory of balance, which dates back to the work of, or at least is often pinned to the work of Fritz Heider in the 1940s. And you could argue, or at least Cartwright and Harari in the 50s argued that what Heider was really trying to do was to formalize the logic inherent in proverbs like the following, right? So proverbs like the friend of my friend is my friend, the enemy of my friend is my enemy, and so forth, right? You can read them all. And these all are proverbs you would hear and you wouldn't really pause. You'd be like, yep, that makes sense. And I guess, not wanting to get, so we can look at these and what they mean, and not wanting to get too kind of computer sciencey about this, but if you look at each of these proverbs, right, it's the blank of my blank is my blank. So there's sort of three variable argument positions there. And each of them takes either friend or enemy, right? So if you think we could actually think of 8 possible proverbs here, right? There's 2 choices times 2 choices times 2 choices. But some of those proverbs wouldn't make any sense at all, right? Like, the friend of my friend is my enemy, right? Crazy, you wouldn't say that. But other ones, like these ones, and I've arguably written down here the 4 that make sense to our human intuition. And if you think about it, to get just a little bit numerological, the 4 that make sense are the ones where the word friend occurs an odd number of times. And the 4 where the word friend occurs an even number of times, they don't make sense. Now, there's actually a very natural reason for this. And it makes sense once you, as Frank Harari did in the 50s, put this into the language of signed networks, okay? So these statements are really about sort of notionally a triangle on 3 people. Because I'm talking about me and my friend and their friend. So 3 people are involved. So let's call them ABC. And they all know each other. And so I have a triangle. And I'm going to put a plus or a minus to indicate friend or enemy. Right? Now again, I have to stress, this is one possible interpretation of what plus and minus means, friend or enemy. And it comes with it a certain logic. Then we'll look at what other pluses and minuses might mean. But friend or enemy. So up to symmetry, there are 4 ways I can put pluses and minuses on a triangle. I can make them all plus. Effectively, if you tell me how many pluses you want to put down, there's only one way to do it up to rotation, right? So I can put 3 pluses, 2 pluses, 1 plus, or no pluses. And what Heider implicitly did in his paper in the 40s was to discuss which of these are more socially or cognitively plausible for people. So in particular, 3 pluses on a triangle is very natural. It's just 3 mutual friends. There's no kind of inherent tension really there that needs to be worked out. And so we'll call that balanced. Balanced triangles are ones that respect kind of the logic of these proverbs and also just don't seem to have any inherent tension. The third one over here, this one, which we also call balanced, what's that? A and B are friends, and they have a mutual enemy, C. And again, there's no real inherent tension that needs to be worked out there either. It's just 2 friends with a mutual enemy. No real opportunity for any alliances to change there. I'm contrasting that with things like this triangle, which we'll declare to be sort of a very clear example of what I'll call an unbalanced triangle, where there is tension that seems to need working out, at least if we think about these as three people, right? So what's going on here? A is friends with B and C, but B and C are enemies, right? So maybe B and C used to be friends, but they had a falling out, or they broke up, or something bad happened. A is still friends with both of them, but there's something here, right? Because when A talks to B, all they hear about is B complaining about what a terrible person C is, but A likes C, right? And so there can be some incentive here, right? A, for example, has some incentive to bring B and C back together, right? To reconcile them, which would transition this triangle back to that one. B, on the other hand, when they talk to A, has an incentive to get A to side with them against C, and maybe change that plus to a minus, which would transition it to that triangle, right? So what I'm arguing is there's some latent potential energy there that wants to get worked out, and resolving itself to a balanced triangle. Okay. And similarly, the triangle with three minuses, which is my fourth choice for what this could look like. Here, balance theory, there's a fork in the road. One branch of balance theory argues that that's unbalanced, maybe the main branch. And the argument there is, if I'm talking about a genuinely high-stakes situation where people all know each other and all have opinions about each other, say countries maintaining diplomatic relations, or a small group of people, a sports team where everybody knows everyone, but some people don't get along, a group of politicians, then what's going on there is you've got three mutual enemies, right? And if I think about high-stakes situations with three mutual enemies, think about, say, the contentious end of a presidential primary season, right? In which you've got people who were in the same political party who were really going at it all spring, saying really mean things about each other. They were, to all outward appearances, enemies. But as the general election approaches, they're facing this third opponent, which is the person from the other party who's been nominated. And so I have a situation with three mutual rivals, right? And the natural conjecture in those situations is that the two who dislike each other the least will find some way to team up against the third one, right? Thereby transitioning this triangle to that triangle, right? So in some sense, May 2008, to go back 4 years, no matter how angry Barack Obama and Hillary Clinton were at each other, you somehow suspected that faced with sort of this third leg of the triangle, namely John McCain, there was going to be some reconciliation. Okay, so that's the theory of balance. And it's a way of interpreting link signs. And you could argue it's sort of a way of interpreting them by saying, if I tell you some stuff about what this network looks like, you should make predictions about what other signs look like to fulfill the logic of balance. Okay. Now, that's not the only thing that link signs could mean. And so here's a completely different interpretation, which will also be useful for understanding some of what's going on here. This is the notion of status. Now, this especially if I think about online domains. This is all about undirected graphs, mutual relationships. But often you form a relationship, A forms a relationship to B. We know A's opinion of B, but we don't know what B thinks of A necessarily. And so maybe when A links positively to B, they're not necessarily saying I like them or I dislike them. They're saying I look up to them. I feel deferential to them. They're above me, right? Plus might mean that. And minus might mean I feel like I'm above them. I outrank them. I'm higher status. I look down on them in some sense, right? Okay. So plus, minus, high status, low status. Now, in the next slide, I'll come to some head-to-head comparisons where these two theories actually predict genuinely different things, and we can start to look at data to ask which one we see more evidence of in these online data sets. At a conceptual level, not only do they make different predictions, specifically, but even if I can't sort of look inside people's heads, if I can't ask them, do you view this person as a friend-enemy or as a kind of higher or low status person? The two theories propose that I should see a different global structure on the network, right? So a network that's governed by balance is really a network that's being driven toward polarization. And this actually is encapsulated even in some mathematical results of Cartwright and Harari from the 1950s. That says, for example, if it's really the case that I have a network and and say everybody knows everybody, and all the triangles are balanced, right? Everything has 3 pluses or 1 plus. They all follow that friend of enemy logic. Then in fact, the network divides into two groups of friends with complete negatives between them. Okay. So it actually imposes this very powerful structure on the network, this polarized structure, where things break into two camps that are at odds with each other. So in a sense, balance, although it's phrased as a theory of local consistency in relations among three people, is also a global theory that talks about polarization. Right? And that's not just some kind of informal relationship, there's really sort of a formal basis for that. Whereas a network governed by status has a sort of different organizing principle. Right? If we think about low status and high status, if everything really completely respected the notion of status, then as a directed graph, we could think of it as having an ordering, a left-right ordering or a top-to-bottom ordering, right? Say a top-to-bottom ordering, so that plus edges point upward in the status hierarchy and minus edges point downward in the status hierarchy. Okay? And that's a very different kind of organizing structure. And so one proposal here is that theory of balance and status, if I'm trying to go in and look at a system where opinions are being expressed, people express opinions about each other, and I want to understand how it's being used, there's almost a kind of forensic question I can ask. I can look at the network itself and say, have the pluses and minuses organized themselves more into a kind of polarized structure or more into a kind of ordered structure? Is there some way of saying that sort of globally balance or status or one or the other is at work here? Okay. So we looked at some of these questions. This is with Jure Leskovec and Dan Huttenlocher. We've actually now been looking at this over a sequence of papers, and we looked at sort of a variety of data sets of the form that I had a few slides back. The trust-distrust network on opinions, which has pluses and minuses. Voting in favor of admin promotion versus voting against admin promotion on Wikipedia. Again, a positive-negative evaluation. Slashdot has you can declare friends on Slashdot, and it being Slashdot, you can also declare foes or enemies when you have negative relations. That's another data. And others have actually come and looked at other domains, such as multiplayer online games, where you can be a friend and you can go on quests together or whatever, or you can be an enemy and you can actually like attack each other with swords. There are a bunch of domains where you can infer pluses and minuses. And one thing that we found, which is quite striking, is that under a number of metrics, there's sort of an aggregate tendency in all of these systems toward structures that are consistent with status. Okay. So what do I mean by structures that are consistent with status? Well, let's suppose, and again, remember that both balance and status as theories, you could say, are making predictions about what sign you should expect to see somewhere in the graph. So suppose I have these three nodes, A, B, and X. And I know that A is negative to X and X is negative to B. And then I ask balance theory and I ask status theory, what would you expect this link sign to be? So balance theory says, well, A and B have a mutual enemy, so maybe they're friends. Right? And indeed, if they were political bloggers, that might be a good guess. If they're both making fun of the same political blogger, maybe they're on the same side. But if I look at these domains, right, the competing thing would be status, which says A looks down on X. A thinks they're higher status, and X thinks they're higher status than B. So in fact, A should think they're much, much higher status than B. So I should expect to see more negatives there. So two theories making opposite predictions. And we find on this kind of structure that, compared to some baseline rate at the sort of rate at which pluses and minuses occur, compared to that baseline rate, you see a preponderance of negatives consistent with a status-based reasoning. You can actually run through all the possible triangles. And actually, if I'm trying to predict this red link, and I have this to work with, I'll come back to this point in a sec. This link could point in either direction, and it could have either sign. This link could point in either direction. It could have either sign. Right? So let's think about that. Right. So this is one example of a structure. This is forward, minus, forward, minus. But this could be forward, backward, plus, minus, forward, backward, plus, minus. So 2 choices times 2 times 2 times 2 is 16 choices. There are actually 16 structures going on here. And that's for one-directional links. I should mention our data sets, when A links to B, generally it's not reciprocated. So normally there's a link one way or the other. Reciprocal links are less common in our data sets. So 16 possible structures. In each of them, balance or status makes a prediction. And overwhelmingly, the prediction of status is the one you actually see. And again, this is not a statement about what the people are thinking as they make these links. It's a statement about the structures that emerge across all the sort of possible distinct structures are consistent with status being applied as the link formation rule. And that's even for ones that were initially surprising to us, right? So B here is positive to X, X is positive to A. Right? Balance theory says this is easy, right? They have a friend in common, they should be friends. Status theory, on the other hand, says, well, B looks up to X, X looks up to A. So A is probably pretty high status. So if you ask A, what do you think of B? A would be polite, I'm sure. A is a nice guy. But A is higher status than B, and maybe you actually expect to see a negative, and that's in fact what you do see. You see a preponderance of negatives. Right? Obviously, you see a bunch of positives here, because the base rate of positives in the whole system is reasonably high. But you see more negatives than you would expect by chance. So what this is saying is it's a way of interpreting by structural means, what principles might be driving the formation of links at a sort of first pass. And I should mention a couple things. One is, it's not all one or all the other. And in fact, you can go into certain parts of the network, and in particular the parts where the links are reciprocated. Parts I haven't drawn here where A links to X and X links to B. And in the parts where the link is reciprocated, you actually see more evidence of balance, as in balance shows up more strongly. And so there's sort of an interesting notion here that when people are linking reciprocally, when they're thinking about each other sort of mutually, the logic of balance somehow comes into play more. When they're thinking asymmetrically, when A links to X, but X may not know anything about A, the structures are much more consistent with status, right? And so it's entirely possible for different of these to be governing principles in different parts of the network. And I think that's also an interesting way of separating out simultaneous uses going on all at the same time. There also, of course, are interesting questions about what this means for the design of sites, right? And so, in particular, all these sites and many others give you a button, right? They say, do you agree with this person, or just, how do you feel about this person? Press a button, plus, minus, right? And you as the user might actually have lots of ways you feel about this person. It's actually multidimensional, and arguably, status and balance are articulating two of those dimensions, right? But somehow the system maybe doesn't let you do that. It just says all of these say plus minus, just tell me, right? And you say, well, no, it's much more complicated than that, and in the end you're shoehorned into saying plus minus. And now it's up to us to sort of decrypt those into their constituent dimensions that were lost when you made that expression. And in particular, balance and status I would summarize as saying there's this lost pair of dimensions that I would sort of call I agree with you versus I respect you, right? Because balance is all about I agree with you, whereas I respect you is more kind of a status ordering. And if you think about it, on many of these sites where there's discussion and there's agreement and disagreement, it's possible to disagree with someone that you respect. It's also possible to agree with someone that you don't respect, right? And to the extent that somehow these are being collapsed, one wonders, of course, whether polarized type structures are emerging in places where they arguably don't necessarily have to, right? Okay, so multiple dimensions being collapsed here. I want to do one slide where I made this notion of dimension just a little more precise, right? I'm saying, what do you mean dimensions? Are status and balance really dimensions? Here's maybe a slightly better way to say it. So in this something that Dan and Jure and I did in some follow-up work. So what we could say is status and balance are really about predicting the sign of a link. So let's just cast that as a prediction task. Here's how I propose to do that. I give you A linking to B, and I hide the link sign, right? And I'm asking, please predict for me whether this is going to be plus or minus. And if you want to imagine a motivating application, A is a user that you're providing advice to, and you want to give them a guess as to how they're going to feel about B. Now, what do I have as evidence? I'm just looking at structure here. Well, I have my 16 possible patterns, right? Remember how this could be forward, backward, plus, minus, so could that. So I say, all right, here's what we know about A and B's relations to third parties, the triangles they're in. A is positive to W, who's positive to B. A is positive to X, who's positive to B. B is negative toward Y, who's negative toward A. And Z is positive toward B, but negative toward A, right? And notice how each of these is one of my types of triangles. Right? I have two copies of the forward plus to W and X. I have one copy of the backward minus, and so forth. So I have 16 numbers here. How many times this pattern occurs? How many times that pattern occurs? Right? There are 16 possible triangles. How many do A and B take part in of each kind? So it's a 16-dimensional vector. That's now basically a machine learning problem where I present you with that 16-dimensional vector. I ask you to make a prediction. And what was interesting to us is you can actually get an algorithm here out of machine learning that predicts link signs that actually has reasonably high accuracy, over 90% accuracy across multiple data sets, even if you train on one and test on another. Okay. And what was intriguing is it really is using those 16 pieces of information. Right? It's a complicated, as a human interpretable theory, it's sort of at the kind of outer limits of comprehensibility. Right? It's not a 10,000 dimensional theory. I didn't dump every feature I could think of. It's only 16 dimensions. But it's using them, right? And what's intriguing is that status and balance, in a sense, are projections of that theory into four different sets of four dimensions. Right? Because balance only sees the undirected triangles. It sees four kinds of triangles. And status, in a sense, only sees four kinds of triangles. And in fact, when you take the learned rule and you sort of project it onto only the parts balance would be able to see, or only parts status, it sort of approximately agrees with status and balance. So in ways that I'm not going to try to really formalize, and we don't really even know how to formalize, it would be intriguing to think that balance and status are sort of the best that we with our human brains have been able to do with this problem, they each have sort of 4 parameters in them, right? We saw with balance very clearly what those were. But they're really both kind of different projections of something that's really, higher dimensional like this, and that we don't fully understand. So I think there's a bunch of intriguing questions there that in this paper we sort of only scratched the surface of via this machine learning rule. I want to mention one other thing about status before moving on to the 2 applications I had in mind. And that was, once we understood that sort of status was going on here, and that we could try to use it as a metric for how people are relating to each other, we started to appreciate a whole bunch of very subtle things about it. So let me just tell you one subtle thing that we discovered. And this was back to Wikipedia voting. And so, again, voting for adminship in Wikipedia, going to be a recurring example because it's really a case where there are these high stakes positive, negative evaluations, right? So a candidate who, again, has quite possibly logged 10,000 or more edits on Wikipedia, comes up for promotion, they want to be an admin, they want to get special Wikipedia privileges. The community votes on them. Now, independent of any structural things, everybody has some measure of achievement in the Wikipedia community when they come up for election, right? So I have, for example, the number of edits I've done, and the candidate, I'm the voter. Candidate has the number of edits they've done. And I could ask, what is the voter? What is my probability of voting positively on the candidate here as a function of the difference between number of edits I've done, number of edits they've done? Just compare our achievement levels directly. So forget this third-party structural stuff. I have a number, you have a number, let's compare numbers, right? And we might have asked, and so Dan, you and I, when we looked at this, you would conjecture that if it's, say, right, so when that number is negative, so I'm below the candidate, I'm looking up to the candidate, then I should have a higher probability of voting positively because they outrank me, I should be impressed by them. And when that number is positive, me minus them is positive, that suggests, okay, I outrank them, I should be looking down on them, I have a lower probability of voting positively. So we should see sort of if we imagine a conceptual plot, like the one I'm now showing here, we should imagine it sort of slopes downward, right? So when I'm below, here I'm below the candidate, and I have a high probability of voting positively. And here I'm above the candidate, I have a lower probability. And so when we first built plots like this for Wikipedia, and you can build actually for all the different languages of Wikipedia, we were happy that indeed the trend kind of went down. And sometimes Dan, Jure, and I, when we do these things, we're kind of a little slow on the uptake, and it took us a few weeks to notice the much more interesting thing with this plot. And the much more interesting thing with this plot, maybe you've seen it already, there is this kind of local min that emerges right around here, right around the 0 difference. And it popped up in a bunch of places. So it popped up here. It popped up with barn stars, which are these badges of merit. It gets very noisy here, but one again sees it's not just a smooth monotonic decrease. But with that account, it showed up very clearly where it's smoother. So we don't quite know what that means, but I can at least read it off literally what the plot is saying. This local minimum here is a local minimum in my probability of voting positively. So voters are particularly harsh on candidates who have roughly the same achievement level that they do. So when you have someone with equal achievement level, you're especially negative. And then as you get to outrank them, you actually start to become a little more positive. Right now, we can think of lots of possible reasons why that might be going on, right? And sort of some of them are about competition, right? You can maybe compare with them. Some of them are perhaps cognitive, that someone equal to me, I can more readily appreciate the faults they have. There are many, many possible things, or possibly, and this is sort of the hypothesis we're leaning more toward, that there's some kind of an aggregate effect going on here. It's really about a population averaging effect more than any one person's behavior. But it's a very, very robust effect. And in fact, for example, if you do this not on English Wikipedia, but you do it on French, German, or Spanish Wikipedia, which again, I should stress, are not translations of each other. They're separate communities evolving independently. So you see similar effects. So it's shifted on the y-axis. In some languages, the voting is just harsher than other languages. But in all of them, there's this dip at 0. It somehow is a robust effect that recurs, and one that we're sort of trying to understand. And with Jure student Ashton Anderson, we've been making some progress on understanding what's going on. Okay, so these are sort of a foundation for thinking about status effects and how it relates to other possible theories like balance and how these play out in online systems, how they help us think about what's going on there and possibly sort of suggest possible ways of exposing this information to people. So now I want to talk about 2 applications of this. And again, there's sort of applications in different directions. The first is going to involve the notion of language and how status doesn't just leak through into the structure of the graph, but it leaks through into the language in some non-obvious ways. And then finally, I'll end with some thoughts on status as incentive and actually how it helped me resolve kind of at least help me think about a conundrum that takes place even in the scientific community, not just online. Okay, so language. So there's, of course, a sort of meta point to be made here, which is I've been talking a lot about structure, about graphs, and about how A links to B and C links to B and so forth. And I talk about, you know, positives and negatives and when things happened and this happened after this thing. And of course, that's because it's very easy for our algorithms to process all of that. But what's really taking place across these edges, right? Rather than thinking about what gets shipped across these edges as black boxes, we could try to open up these black boxes. And of course, the black boxes in general will be made of language. People are actually communicating with each other in language. And we actually look at that, right? And even if I just caught snippets of what they were saying, right? You know, what was that thing I was going to tell you? I need you to do this thing. Could I ask whether? Even from these little phrases that convey zero content in a sense, I can probably start to make estimates about how these people feel about each other and sort of who thinks they're in a power position compared to whom and so forth. And so one question is, you know, how are we doing this, right? Can we actually detect status and power differences from just differences in the patterns of language use? And often even just from the patterns of incidental language, right? Language like this, language with very sort of functional parts of speech. Okay, so there's been sort of a line of work on this. The idea we had was to sort of look at these low-level signals from function words using a social psychological principle known as language coordination and try to argue that that actually ends up providing a signal about status and power differences. So let me tell you how that works, starting with how language coordination works. Okay, so language coordination, some of you I know are of course familiar with this concept. When you first see it, it's a little surprising. And so I'll actually start with an example from two of my co-authors, Cristian Danescu-Niculescu-Mizil and Lillian Lee, where they actually went through the scripts of roughly 1,000 movies to discover that this phenomenon actually even takes place in movie dialogue, which is funny in a way because those conversations never actually took place, right? They all happened in a screenwriter's head. So here's an example. This is one of a zillion examples, of course. This is the 1970 movie The Getaway. That's Steve McQueen. That's Ally McGraw. Steve McQueen says in this little snippet of dialogue, "At least you're outside," and Ally McGraw says, "It doesn't make much difference." Okay. So something to notice here. Steve McQueen uses a quantity word, least, a quantifier. And Ally McGraw responds by including a quantity word, much. Okay. Kind of a minor point, but it didn't have to be that way. She could have said it doesn't really matter. She could have said it's not really important, but she didn't. She said it doesn't make much difference, right? She echoed his quantity word. Now, you might say, well, that's a coincidence. And in any one instance, maybe it is. But the point is, there actually is this aggregate statistical tendency that you will actually imitate the function word choices of the person you're talking to. Now, this is arguably a little surprising, right? And this comes out of work by people like Jamie Pennebaker and his colleagues, where you look at, for example, things like prepositions, articles, conjunctions, right? If you're talking to someone who uses a lot of prepositions, then subconsciously you will begin increasing your rate of preposition usage, right? And the argument here is that it's subconscious, right? The psychological argument. I mean, because, for example, you have no idea how many prepositions I just used in my previous sentence. I have no idea either, right? And if you put people in a lab and ask them to increase their preposition use, it's hard for them, right? But they're doing it somehow. And of course, coordination is something that happens at many, many levels, right? So if you're talking in person, there's coordination on posture, right? You cross your arms. Like after a while, my co-authors, Cristian, Lillian, and I, it was hard to even have meetings, right? Because one of us would cross our arms, we'd wait for the other person to cross their arms. Because it does happen. You should try it, you know. And you grad students out there, you can try it on your advisor when you're talking to them. You can sort of, you know, you coordinate all sorts of things. Our hypothesis was that even not in person, even, you know, both online and offline, that if there's a status or power imbalance, then we want to argue the lower person is going to coordinate more in aggregate, right? These are very subtle effects. And the high power person will coordinate less. Okay? Somehow reflecting the power difference between them, right? Right, if you think of this as a kind of, I'm very attuned to you, I'm trying to sort of accommodate to you, the lower power person will do that more. Okay. All right, so, and it thereby would provide a kind of signal. And there was not really much evidence for or against this. I mean, in some of the work of, for example, Nierdorfer and Pennebaker, they looked at the Nixon-Watergate transcripts. But that was like Nixon and 3 of his aides, Haldeman, Ehrlichman, and Dean, and looked at levels of coordination there. In the end, that's about 1 person and 3 of their counterparties in conversation. We want to do this at a sort of much, much larger scale. Okay, so to do this, first of all, we need to actually have a measure of coordination. I've sort of said, well, you increase your usage of this thing. How do we actually want to measure that? So this is a formula. This is sort of one of my 2 little formulas that I'm going to use here. In some work that our co-author Cristian did with Sue Dumais and Michael Gaiman at Microsoft Research. And the idea was to say, when person A uses a word of type T, like a quantifier or a preposition or a conjunction or whatever, does this raise B's chance of using a word of type T in the very next utterance? Right? Now, the thing we want to do here is control for, this has to be the very next utterance, and we want to control for the base rate at which person B uses type T and when they're talking to A. Because maybe B just uses a lot of prepositions. Or maybe B uses a lot of prepositions when they talk to A. Because maybe when A and B get together, their topic is always how they're going to redecorate their apartments. And it's always about, I'm going to put the vase on the table, under the picture, behind the sofa, right? And so it's a preposition-rich topic, maybe. So I want to control for all that. I want to say, but did you use a preposition in the very next sentence after they did it, right? So that suggests a very natural measure. It's just the probability B uses type T, given that A used it in the very previous utterance, versus minus probability that B uses type T, given that simply they're replying to A. Okay. All right. So that's our measure. And so first I'll just show you a plot that actually, for starters, establishes that this thing is really happening in sort of a large data set. And secondly, shows some of the status differentials. So kind of the thing to remember is this is a very small change in probability. This is a very subtle effect. So we'll kind of scale it up. We'll do it as a percentage, multiplied by 100. So I'll show you some bar graphs for different parts of speech. And if they go up, that means this number is positive and it's really happening in a statistically significant way based on the error bars. They could go below. The bars could point down, meaning negative coordination. I'm actually anti-coordinating to you. Use a preposition, I back off from preposition. That could equally well happen. The first data set I want to talk about is one that's very, very clean for this purpose, and actually a very nice language resource that came out of research here by Timothy Hawes, Jimmy Lin, and Philip Resnick, a large annotated transcript of Supreme Court arguments, oral arguments before the Supreme Court. This is nice because there's a very clear status differential. There are lawyers talking to justices, and so there's it's very obvious which way the direction of status goes. And so we could ask, do lawyers coordinate more justices? And so here's this plot. Okay, so these bars are how much you coordinate on quantifiers, adverbs, conjunctions, articles, and so forth. Bars go up, coordination is happening, and to a statistically very significant extent. And the purple bar is how much lawyers coordinate to justices, and the green bar is how much justices coordinate to lawyers, right? And there's a big separation between them. Lawyers are coordinating justices more, right? So once you see a thing like this, you sort of feel like you're sort of on the right track, because it's this invisible frequency. Like if you're not tuned into it, you're not noticing uses of these function words. But once you tune in the frequency, you start discovering that it's actually giving you the signal about who has higher status than whom here. So we looked at this. This is an offline domain, and there are lots of things going on here, right? They're physically looking at each other in person. We went back to one of our favorite domains, Wikipedia admin promotion cases. Looked at how do people, because one nice thing with an admin promotion is we've got the full text that they are typing over their whole course of their Wikipedia career. And at some moment, they literally experienced a status change. They got promoted. So the question is, does your level of coordination change when you become promoted, right? Do you start, what would the hypothesis be? You should start coordinating less because you now have higher status, and others should coordinate more to you. So here's that time series. Okay. So here's an average. So we took everybody got promoted. Time 0 is when they got promoted. This is minus 1 month plus 1, 2, 3 months. This is their level of coordination to the world. This is the world's coordination to them, right? So this is differential. And at the 1 month point, somehow they still haven't, the world hasn't quite caught up to the fact that they now have higher status. But then they start to cross, right? And so it's, again, this notion that even for the same person, right, you change the status, you change this coordination measure. So there's stuff going on here. So, OK. And there's a bunch of other stuff going on here that I won't have time to get into. But of course, there's other selection effects, right? People who succeed at admin promotion are a different population than those who fail. Those who fail at promotion also undergo a trajectory that this is interesting to look at. One other thing I wanted to mention was there's this notion in social exchange theory, for example, that if you generalize from status to power, power can reside in different things, right? Power could be about status difference, right? That's a kind of locked-in static notion of power. But power can also be situational. You could temporarily have power over me because I really need something from you right now, right? And so in particular, if I'm trying to convince you of something, convince you to change your mind, you have this situational form of power. And the question is, does that also get reflected here? So where do we see situational power? Let's go back to the Supreme Court. You can do it on Wikipedia also, where the candidate is actually talking to the people who are arguing with the people who are going to vote on their case. Supreme Court, you go into the case, and you know that certain justices, just based on party alignment and so forth, are predisposed toward your side, and others are predisposed against your side. So the question is, how do you coordinate to people who are going to ultimately end up voting for or against you? So this is what I plot here. So here what we have is lawyers talking to justices, and we separate the justices into those who end up voting with the lawyer's side or against the lawyer's side. Now, arguably, the lawyer should be somehow is experiencing a bigger power differential when they're trying to talk to the opposite side, because that's the side they really need to change. And indeed, we see that there's actually a large amount more coordination when the lawyer talks to the opposite side. And the funny thing is that you go the other direction too, right? When there's a high power differential, the high power person should coordinate less. And sure enough, when you look at the speaker as the justice, right? Now there's more coordination when the justice is talking to someone they end up voting for, because there's less power differential. And when talking to someone who they're going to end up voting against, bigger power differential, less coordination. Right? So again, it's this kind of invisible signal you're picking up where, yes, the justices are coming in and they're impartial, they're going to reach a decision, but even in their choice of prepositions and adverbs and other function words, they're already somehow signaling something about which side they're aligned with. Right? And that's going on below sort of the level of anyone's conscious perception. Okay, so now you could ask how this works in a predictive capacity. And there's sort of two things to say about this. And right, so I could do prediction. I could say, taking a bunch of text, could I predict who is the higher power person in either Wikipedia or in the Supreme Court? Now, these are subtle effects, so they aren't going to solve the problem on their own. Right? They're saying there is signal here, right? And it's a fairly unambiguous signal. But as a feature in itself, it's not necessarily going to be the solution. But what we argue at the beginning is it's the kind of feature that we see that we feel like is unusual in its ability to generalize across domains. So here's what we did. We did some machine learning, and we just did sort of vanilla machine learning here. So we said, let's do support vector machines. Let's take a bunch of features, and we're going to do three kinds of features. So first we're going to do bag of words. Take the sort of top 20,000 words in the vocabulary, train an SVM to figure out who has in pairs of utterances, which is the higher power person. Okay. Then we're going to do coordination features, which are basically the heights of the bars in this graph. That's nine dimensions instead of 20,000, much more streamlined representation. And we'll also do, we'll double that. So we'll do what we'll call stylistic features, which is not the heights of the bars, but simply the amount of function word use by one speaker and by the other speaker. Okay, so just look at function words. So this is Supreme Court, and this is how the performance of different things did. Now in Supreme Court, looking at vocabulary just cleans up. And that's not surprising, because actually the dialogue in the court is structured in a very, very stylized way, right? The lawyer says, may it please the court. They say, Your Honor. So if you're looking at utterance and it includes Your Honor, that's the lawyer. Okay. And the support vector machine is smart enough to pick up on that. So it knocks that one out of the park. And coordination does reasonable, but it's not going to compete with that. If you look at Wikipedia, though, no one on Wikipedia says Your Honor or uses any particular terms of respect. And suddenly the vocabulary does terribly. It does statistically no different from chance guessing. And now the coordination stylistic features are doing better, right? So coordination is somehow the only one significant across domains. And in fact is a cross-domain feature, which means I can actually train it on Supreme Court transcripts. I could build a model and train on Supreme Court transcripts. And I could go over to Wikipedia and try to figure out who has higher status. Okay? If I do that with words, it actually overfits badly, and I actually get statistically indistinguishable from chance guessing, although lower. If I do stylistic, I get nothing. But if I do coordination, it actually survives basically almost undiminished, right? I still get good predictive performance. And similarly in the other direction. I train on Wikipedia, I go to the Supreme Court and ask who has higher status. Coordination survives across that. Okay. So again, it's a signal that one has to intelligently combine with other things. It's not going to solve the whole problem itself. But it somehow is a genuinely cross-domain signal. You can statistically significantly reasonable prediction even when you're looking across the domain. Okay, so that was one application. That was about language. And I wanted to spend about maybe 8-9 minutes as the final topic thinking about one other issue, which I think is sort of an interesting issue to put out there and just some thoughts we had on it. And that is status as an incentive. Okay, so this is about detecting status from data. But there's this notion that we set up these systems that confer status to try to induce you to behave in certain ways, right? And online, we see that again in a number of settings, right? So if you look at not just Wikipedia, which we've been talking about, but say on open source projects where many people collaborate to solve problems, on question answering sites like Stack Overflow, you see people working to achieve high status on the site, right? Some people call it the gamification of the site, in which you create incentives and that channels behavior in certain directions. And you often see people sort of auditioning for high status roles, hoping the community will notice them. Okay. Now, there are very close analogies here to status seeking incentives in the offline world. And here again, I'll come back to sort of the scientific analogy. And let me actually run with the scientific analogy a bit, because thinking about this with my student Sigal Oren, I felt like helped shed light on things that just, as a practitioner of science, I have noticed over my career. And I felt like this notion of status seeking as an incentive was kind of useful. So status is conferred in the scientific world as well. Your paper gets accepted or not, your grant proposal gets funded or not, someone gets hired or not, someone receives an award, and so forth. Lots and lots of conferral of status. And I would argue that, yes, it's a decentralized process, but much more so than in the real economy, say, to some extent science is a planned economy, right? There really is a committee that gets together and says, whose paper should we accept? And not only that, they ask the meta question, what signal will that send to the community as to what they should be working on? Right? Now, what's funny here is that these signals and how they get sent, that's obviously the subject of a lot of discussion, right? And if you stand in the hallway at any conference, you'll hear people discussing how the incentive system has gotten out of whack, the wrong papers are getting accepted, the wrong work is being rewarded. And this sort of got thrown into relief by me when I received the following manifesto in my email about 5 years ago now, written by a very thought-provoking thing, written by some of the most eminent people in theoretical computer science. And they were saying, let us know what you think of this. They were arguing that, in particular, CS theory conferences, but this is an argument made in almost every community I have encountered, that the wrong papers are getting accepted, right? So there are these important conceptual advances that get rejected, and there are these other papers that are technically difficult, technically intricate, and somehow everyone seems to agree that they're less important, but they're the ones that keep getting accepted. And somehow, why is this happening, right? But somehow, the fact that it keeps happening makes you feel like there's something systemic here, right? This is not just about people being stupid, but the community keeps falling back into this pattern of behavior. What is it that's so attractive about this fascination with hard technical things, even when we all agree it's less important, maybe we can't break out of that pattern. So we started thinking about that. This is my student Sigal and I. And first of all, we noticed there are really sort of two kinds of things going on here when we think about status as an incentive and what kind of pathologies we're talking about. And I would divide the two pathologies into pathologies about questions and pathologies about the people who work on the questions. So the pathology about questions is that certain research questions receive an unfair amount of credit, and that's what this petition was really talking about. The other is that certain people receive an unfair amount of credit, right? And this actually is an even older notion, and this goes back to a long literature in the sociology of science, some data back to Robert Merton's articulation of the Matthew effect, that when two researchers both solve a problem, independently maybe, the more famous one tends to get more of the credit, right? So you tend to view it as, oh, it's that, you tend to refer to it as that famous person's work and not say it was co-discovered, right? And he named it the Matthew effect, not because someone named Matthew was the perpetrator, but because of this line from the book of Matthew in the New Testament of the Bible, which says roughly that they that already have shall get more, and they that don't have very much shall lose even that, right? The rich get richer and take away from the poor. Okay, so why are all these things going on? And again, I want to argue there's something systemic about it. Right? So once we realized this, we realized, okay, lots of communities have actually thought about this. So work in the philosophy of science about credit as incentives, economics of science, theories of research and development, right? And there are lots of apt quotes. This sort of summarizes what we've already been saying by the French social philosopher Pierre Bourdieu about how researchers' motivations are organized by reference to the anticipation of symbolic profit, right, credit. And they tend to concentrate on problems regarded as the most important ones, but of course that triggers intense competition, which makes you less likely to get the credit on that. Right, there's a hotspot there where everyone's competing. So some researchers depart to other objects which are less prestigious but with less competition, and the whole thing balances out. Right? Which, for a French social philosopher, is a remarkably apt description of load shedding in a distributed system. Right? There's this appealing thing, hotspot builds up, people move off. Right? Okay, that was the idea. So we want to try modeling this, and so the sort of final thing I wanted to bring up was a very simple model you can play with, and some surprising consequences from it. So here's the model. So it's a game theoretic model. We're going to play a game. And in a game, players have strategies. They they choose a strategy, they all play them simultaneously, and they get rewards called payoffs. So in this game, each researcher is a player in the game. And there are certain projects. And this is a very simple stylized model that you could choose to work on. So basically, each project is simply, say, an open math problem. You go, you think about it for 6 months, you either solve it or you don't. You succeed or fail. So projects are described by only two parameters. Their importance, or their weight, right? X has a weight, WX, and their difficulty, which I'll call F sub X. If you go work on problem X, you fail with probability F sub X. You succeed with probability 1 minus F sub X. OK. So, and we pick strategies. Everyone picks something to work on. And let's say KJ is the number of players who choose project J. So there are two quantities I might be interested in here. One is society's expected benefit from the research that gets done. And the other is each player's expected benefit. So society's benefit, what is that? Well, it's the sum over all projects J of the value to society, the expected value from having it get worked on. Well, if KJ players work on it, we benefit if it gets solved, right? So in order to get solved, everybody has to not fail. So if everyone fails, if that probability 1 minus that is someone succeeded, and we get that weight. Okay, we sum that over all projects. That's society's benefit from all the work they got done. But a player experiences benefit differently, right? So if you go work on project J, well, this is the reward that comes out of solving it. And if KJ players are working on it, your chance of receiving that reward is 1 over KJ. Okay. So this is what society gets, but this is your payoff. This is sort of your expected increase in status to your credit. That's now a game, and society's interests may be aligned or not aligned here. Let me work out an example, and we'll kind of see these pathologies in action, and then I'll wrap up with some conclusions. So, OK. So we're going to look at society. It may or may not be optimal. So I'm going to take a really simple simple instance of this problem. 2 researchers, 2 problems they could choose to work on. This problem has importance 1, difficulty 1/2. This problem has importance 9/10, difficulty 2/3. This one is the less important but harder problem. Okay. On the left, I'm showing you what we'll call the Nash equilibrium. Each player chooses a strategy so that no one has an incentive to change what they're doing. And the unique Nash equilibrium in this game is that both players choose X. Because in that case, X will get solved with probably 3/4. One of them will get the credit, so each player gets an expected benefit of 3/8. 3/4 chance it gets solved, probably half I get that credit. Whereas if I switch to the lower problem, well, I solve with probably 1/3 and I would get 9/10, so that's only 3/10. That's worse. So they'll both go after the low-hanging fruit. But society doesn't actually want that outcome. Society would do better if they could get A to work on X and B to work on Y. Because then they wouldn't get 3/4 as society's benefit. They'd get half from the top, 3/10 from the bottom, 4/5. So society doesn't want all that piling up on X. But the competition isn't chasing them away. OK, fine. So far, this is just a story of Nash equilibriums don't always lead to the optimal outcome. We've seen that story before. The Prisoner's Dilemma shows that. Tragedy of the Commons shows that. But remember, this is science. This is a planned economy. Suppose you were in charge of the scientific community. Could you do something about this problem? The answer is, of course, in this simple example, you could. You could say, all right, we all know that these are the real importances of the problem. No one's disagreeing about that. But let's pretend that if you happen to solve problem Y, you'll actually get a credit of 6/5, bigger than 1. I'm going to inflate the amount of credit assigned to that problem. Now there's a new Nash equilibrium, and it's that one. And that one is socially optimal. So another way to put it is, in order to get optimal productivity from this community, we need to invent an artificial currency in credit in which we unfairly allocate credit and give more to that particular problem. Right? And society benefits. And I could do it a different way, a way that resembles the Matthew effect. I could say, all right, I agree you 2 people are equal researchers. But should you happen to compete, I'm going to assign credit in relative shares of, say, 5/1. Right? So if you both solve the problem, A will get the credit with probably 5/6, B will get the credit with probably 1/6. Why? I don't know. There's some symmetry breaking. A is taller, more attractive, came from a better, high school. I don't know what, right? But that's how it's going to be. Now, suddenly, there's, again, a new Nash equilibrium. B decides, not worth competing anymore. Because if we compete on this low-hanging fruit, I'm not going to get the credit anyway. So they go and they work on Y, and again, we have social optimality. And this, too, tells us something. It says, and this is not, I'm not saying this is a good message. I'm not saying this is fair or this is desirable, but it's basically, let's again read this literally. It says, if you unfairly marginalize certain people, like B here, they are forced to go pursue higher risk courses of action that actually are benefiting society as a whole. Right? And so, right, it's a kind of Matthew effect. Now, so what's going on with these 2 examples? And I should say, these aren't just examples. The theorem that we prove in our paper is that for any set of players and projects they could work on, right? It can be a very complicated set. there is always a Nash equilibrium that reweights, there's always a reweighting of the projects that gives you a socially optimal Nash equilibrium. Or if you want to work on the left-hand side and do the Matthew effect, there's always a reweighting of the players that gives a Nash, such that all the Nash equilibrium are socially optimal. Right? I can always create incentive schemes that produce social optimality. Okay? So it's not saying that this is why this is happening, right? It's not saying that program committees are getting together and computing these weights. But it is saying that people engage in these meta discussions about how do we want to steer the community's effort. The problem is, to the extent that this is a human bias toward doing certain things, it's unfortunately an attractive bias to fall into, right? It's a hard bias to correct because, in a sense, collective productivity may actually be higher in the unfair world than in the fair world. Right? So when you go clean up your act and make things fairer, you may actually be decreasing productivity, right? And so the argument is simply, there's a certain robustness to this pathology, right? The fact that pathology keeps happening suggests empirically it's robust. And this is somehow arguing that somehow at the level of this model, there's a certain robustness to it. It's productivity increasing. Okay. There's some thoughts on how you prove this, which I'll skip. There's a bunch of potential interpretations, which we talked about, right? Competition, marginalizing people, crowding, right? The crowding effects of communities. A bunch of open questions here. I think there's actually an appealing, sort of very simple scaffolding which to hang a bunch of questions about incentives, both for the scientific community and also for the design of online systems, where you have even more flexibility to design incentive systems, right? How do you reward collaboration, right? 3 people do something, how do you divide the credit? Projects are dependent on each other. I did the hard step, and you thereby did the sort of very high-profile, visible, easy follow-up step. Who should get the credit? Products are arriving at all times. A product arrives, we don't actually know how hard it is, right? We should all try it out maybe, get an estimate of how hard it is. How do we handle limited information and things that arrive dynamically? And I think more generally, if I think about systems, and science is a system like this, but online, right? Open source projects, question answering sites, collaborative work sites, all of these are systems where I would argue conferral of status can become part of the design space. Right? How I choose to confer status will channel effort one way or another, and this argument that there can be subtle effects. Okay, so last slide. This is sort of general challenge we've been talking about, right? You see opinions, evaluations being formed. You don't always know why it's happening. But to the extent that we can actually develop models that provide us with a vocabulary for that, it can help us understand how these are being used and potentially suggest metrics that we could surface to users, right, about where status resides or where power resides. And also design principles about how we could take people's inherent seeking of status and channel it towards certain outcomes. Okay? And so I think overall, there's sort of this nice opportunity, both using empirical analysis, both using data, and also using models for these kinds of behaviors, to take all of these ideas, these computational ideas, and try to think about how we might design systems that take advantage of these forces that channel them and potentially produce new kinds of outcomes. Thanks very much.
We'll take a few questions.
How did you know that you're actually improving the benefit of society when these committees change the weight of the...
You mean the real committees or these ones in my little model here?
Either one.
The ones in my little model I can just calculate it. So,
well, I mean, I guess I really mean the real committees.
Oh, the real committees. I don't. So, right. I mean, so as I said, the aesthetic here is, can we think about a model in which these kinds of effects could actually be socially, say, desirable still appropriately, right? And so what this is arguing is that rewarding the wrong things can actually be productivity enhancing, right? And these are essentially examples of what happen. And it's sort of an argument that this is a general phenomenon. You can find this in all of them. And so you can argue it's a proposal for why this might, one force that may be in play. As I said, no one's arguing the committees sit down and discuss how they're going to be deliberately unfair to people. But it does say that to the extent that certain changes can be productivity enhancing, they may be more robust.
I guess could they be doing the opposite?
Could be doing the opposite. You can also make decisions that worsen productivity. I mean, so one thing we've thought about, we've actually talked with some people working in the sociology of science. Can we actually look at, say, lifetime citation counts and choices of work by people and rejection rates? And could one try to fit some kind of model to what's going on? I think it's a very interesting question.
But how can you predict the benefit to society of a result, a certain result?
So, I mean, one thing, so there are metrics. So two possibilities are, let's say, benefit of, so citation counts are in some sense self-referential, right? But one is certain things eventually get large citation counts that initially weren't, right? And so when we use a metric, things like that. The other, I guess, is benefit to society is one interpretation. Another sort of external visibility, right? So suppose different communities are being evaluated by a single entity, say like a large funding agency. Right? So now what that's saying is if the funding agency is evaluating that community's outcome and rewarding it with more or less funding, the community itself needs to, again, invent this artificial currency in order to make itself seem as appealing as possible. Right? So the external view is different from the internal view. And that actually is something one could try to look at with data, where essentially what's being valued by the umbrella in the funding agency may be different from what the community is valuing, and we'll try to see that.
So I appreciated some of the anecdotes that you dropped in here about how some of your work was affecting your own communication with like your students or maybe your colleagues, like the language coordination model. I was wondering, with this last example, if you thought about, or if you've seen it affect your thoughts or your approaches, or you've taken also leadership positions about the way that communities are approaching problems and problem spaces, and even personally, have you sort of changed your work practice at all? Or your
it's a good question, yeah. So yeah, so here it's, so right, the question is sort of, have it affected? I mean, so I think back to this, and I found this a very interesting discussion to have, for example, and in the end, my answer at the time was, I don't know what I think of this manifesto because it just seems like a really hard problem when you think about it. And in some sense, the remaining slides were me thinking about it. Yeah, so I mean, one thing this says is, there's sort of a right, so there's sort of this rhetoric around breakthrough versus incremental work, for example. We were talking about at lunch, but I feel like it relates to that in the following sense, that one dangerous thing about that rhetoric is that the terms tend to be, words like breakthrough on one hand and words like incremental on the other hand. And who wouldn't prefer breakthroughs to incremental work, right? But I feel like by adopting that rhetoric, one sort of overly devaluing one side, right? Because not everything can or should be a breakthrough, right? Continuous breakthroughs are not actually necessarily a way to advance science. So I think a better discussion of this argument is what's the optimal mix, right? Now, if we're going to talk about the optimal mix, maybe breakthrough versus incremental is not the right terminology, right? But really, sort of, first of all, there's the risk-reward trade-off, right? So I think one thing that sort of this informed a little bit is, if we think about these two parameters, importance and difficulty, there's some kind of curve that's trading off risk versus reward. And there are also other things that aren't quite in the model that I think are sort of implied by it, the sort of time horizon, right? Breakthrough implies sort of, I'm thinking long range about, but there needs to be sort of the follow through on that work. So I think, yeah, one thing this has helped me with is in these discussions about how, that we should be reconfiguring science so that everything can be a breakthrough, we should ask, is that really the goal, or is it really that we as sort of a community should be trying to find the optimal mix of those activities?
So John was probing how it changed your behavior. So did you go after more risky problems?
Well, we can now model, this.
We should now look at.
We can now model the model.
It's actually right. It's a question best asked not to me, but by looking at what I've done. And
actually, an extension of that is a question that very much happens in this community is about the choice of independent and dependent variables in terms of what you can influence.
Yeah.
So, for example, as you were looking at the admins, or let's say the Supreme Court justice, you were showing results about what happened. Yeah. But you weren't saying we had no evidence, or that if a person mimics a judge, they can change the judge's opinion. Yeah. Does a coordination, a forced coordination, produce a change in behavior?
Interesting question. Yeah. So that's actually that's a nice open. That particular question, and I'll get back to the broader point. Is a nice open question. If I ask people to coordinate, what's going to happen? And in some sense, to what extent is this causal? As in, if I coordinate more, yeah. Those are open questions. They're open questions at the level of lab studies also. You put people together and you tell them, try coordinating, see what happens. The results are quite mixed there. So the question of how do you design your language to be effective, that's actually a question we've been thinking about a fair amount. Right, so strategically, how should I engineer my language? We went back to something in a sense more primitive than this. This is not in the talk, but I'll digress onto this. One follow-up that we did, we brought in Justin Chang, who's a Cornell undergrad, undergrad student at Stanford. Looking at what makes for effective language. And we thought, where's the source we can measure the effectiveness of language? We went to the movie transcripts that Cristian and Lillian Lee compiled, right? 1,000 complete scripts of movies, each with 1,000 lines. That's about 1 million lines of movie text. Some of which are famous, right? I mean, some of which are, you can't handle the truth, you haven't handled all these things that are now internet memes everywhere, right? And the question is, could we find, you can take measures of memorability. You go to IMDb and find what memorable lines. If you go to Google, you could just say, there's a Google count for that quote every time it appears on the web. Let's ask, are there recurring features of those, right? If you want to engineer your sentence, what are the properties of the sentence? And the funny thing was there actually were these recurring patterns in those sentences. Again, not conclusive, but a subtle but clear leaning towards certain things. So in particular, again, I'm digressing onto a paper I didn't cover here, but it is about how to engineer effective language. Right? And so one thing that sort of came through quite good in terms of lines that were memorable from movies is, to a statistically significant extent, they were unusual in their word choice. Right? So take Newswire and build a language model of that, how likely sequences would look. And then evaluate the likelihood of lines from movies according to Newswire. And look at the average likelihood of the memorable lines. Memorable lines had unusual less likely word sequences. But if you went down to the part of speech level, so just look at noun, verb, adjective, whatever, their part of speech sequences were more likely.
So familiar words but used in a novel way that makes
exactly. So the its sort of distinctive word choice is hung on a familiar scaffolding of common part of speech. So in the same sense that, right, so like you had me at hello, which Renee Zellweger tearfully says in Jerry Maguire, has the same part of speech sequence as I met him in Boston, right? An unmemorable line. Same part of speech sequence, right? But it's sort of the unusual words that you hung over that way. And so that kind of, we felt like the one qualitative takeaway, that it's important to be sort of unusual at the right level, right? At the word level, it's good to be unusual, but at some structural level, you should not be unusual. That's not about how to win Supreme Court arguments. That's about a different. But I think this is definitely a path that we want to start heading down. Of what are the recurring properties of effective language, where effective memorability?
Or how do you become an emit?
Yeah.
You showed us what happened, but it didn't affect the variables that I could shape as my
exactly. So
aspiration.
what is it you should be doing to
All right. We'll take two more.
Actually, one quick one. Can you predict Supreme Court?
Yeah, everyone else does that. Yeah. So could you predict how people are going to vote? Again, it's a weak signal. So we haven't actually we have not done exactly that test. We had this. We were doing this during the after the healthcare arguments before the decision, and a zillion people asked us, so who was coordinating how in healthcare? And we did go back and do that. It was, as with any one individual case, it was complicated. It didn't follow it. What seemed to be happening there was a lot of everybody was coordinating more to the U.S. Solicitor General, and we actually found in the data, U.S. Solicitor General, unfortunately, is a high status position, and so there can be that kind of coordination happening also. So it was complicated. So we have not yet, and actually some of the work going on here at U Maryland, the people like Philip and Jim and Lynn have been doing, also I think sheds light on trying to build up some questions like that. Could you predict that?
Well, my real question is the real question. I sort of worry about the simplifying assumptions in this model, like things like, it might be that if you have a question and you might need just one person to work on it to solve it, and have like 100 people working on it doesn't help.
To jump ahead, definitely, right. I agree. I think a lot of nice open questions that just...
Or nobody can solve it.
Right, could be impossible. But the idea of what 100 people to work on it is, or is there actually super additive benefit? Like, if we work together, we can share ideas. Yeah.
Tim.
I'll take that up.
I was wondering if you thought of cases in which someone resists or through sort of lack of perception doesn't conform, so anti-conformal behavior, and how that might play out in the dynamics of a social situation. And I was thinking of this case because if you haven't tested this, it could be a test of how general your model is against, say, if there is any empirical data out there about how such actual social situations unfold.
Right, so training people are sort of actively not coordinating. Not something that we've looked at, but I agree that this notion of sort of anti-coordination or non-coordination is an interesting way to vary the conditions.
And we'll let you have the last one here.
In your earlier example regarding the positive influence of the addition of words, I wonder if those words had a negative weight, so like somebody who swears a lot, those words are negative, would it have a positive influence on somebody who doesn't swear, or would it have a negative influence on somebody who doesn't swear?
I see, you mean when you're matching, if it's sort of...
Yeah, because that would be an interesting thing.
Right, so you're saying if you echo, that might actually be bad in certain situations. Yeah, so I mean, a couple of ways one could... We've asked this question, we're actually looking at some of this in the data, about repetition at levels more fine-grained than word classes. And then we can start to ask exactly some of those questions. At the moment, we're really asking about word class imitation, not direct word. So, use a preposition, I use a preposition. So these are all innocuous function word classes that you're basically using to build the structure of your sentence, but that are not really content-bearing. But asking about repetition of other words that either may carry content or be more specific is certainly, would be one of the other ways.
All right, those who want, continue up front, but thank you all for coming, and thank you, Jeff.